So let's kick things up a bit and add MongoDB into our project. So you're going to want to install MongoDB on your system. I'm not going to explain how to do that. There are a million tutorials out there explaining how to do that. So install MongoDB on your system, and then we will jump in to the rest of the video. So finally, we're onto the database. So in this part, we're going to take everything we've done before, take the hard-coded data, and we're going to shove it into a database, create connections to the database so we can interact with it, pull stuff out, put stuff in, etc. Link that up with our routes in our API, and then we will be done. So in the real world, what database to choose is actually quite a big decision, and all too regularly, it actually gets overlooked. People just pick the one they're most comfortable with, or the one that's like the coolest right now or whatever, and that's really not the best approach. You should be choosing the best tool for the job in all situations. So sometimes the best tool for the job is going to be a NoSQL database like MongoDB, and other times it's going to be a relational database like MySQL. But then other times it'll be something else like fancy graph database like Neo4j or something like that. So you should definitely dig into these different databases to figure out what they're good at, what they're weak at. So for every given project that you work on, you can always choose the best tool for the job. But with that said, this is a beginner tutorial and we're just trying to get something spun up. The use case is very simple, so we're just going to use the simplest one to get set up and working with immediately, and that is MongoDB. So to start with, you're going to want to install Mongo on your system. So we're not going to interact with MongoDB directly. Instead, we're going to use a library called Mongoose. And what Mongoose is something called an object model for MongoDB. So let's install Mongoose, and then I'll go into a bit of detail about what it actually is. So we can install it using yarn add mongoose. An object model is simply a bridge between the way we think about data in the code versus the way we think about data in the database. In JavaScript, we have objects, and we can put whatever we want into those objects. By default, there's no way for us to validate the types of any of the properties in that object. When we're in database land, we're going to want to know what those types are, and even what the specific properties are within the object. So we're going to need some kind of validation to ensure everything is what we expect. An object model, like Mongoose, acts as a bridge between those two universes. In our code, we can use JavaScript objects. And when we want to put that object into the database, we pass it to Mongoose, and then Mongoose handles it from there. Mongoose will then use the validation rules, also known as the schema, that we defined to make sure that that object is valid. These validation rules will be things like checking if a certain property is a string while this other property is a number. And these rules can be as complex as we need them to be. If the data is valid, it ends up in the database. But if it's not, we get an error. So basically, Mongoose is the data gatekeeper for our MongoDB. So jumping into our facts model file, this is where we're going to want to create the actual structure for our facts using the Mongoose object model. So to start with, we're going to want to import Mongoose. So let's go here and import Mongoose, require Mongoose. And this Mongoose object comes with a few little things that we're going to need. One of them is a class called schema, and we can use that to define the structure or schema of our facts. So we can do that like so. We'll call it fact schema, and that equals a new mongoose.schema. And then into that we pass an object, and this object will define the structure of one of our facts. And that might look something like this. We'll have a fact type, and that is just a string. And we'll have a fact image URL, that will also be a string. Fact data, and this won't be a string, instead this will be an object. Note here that we've specified that this is an object, but we have no extra validation for what actually goes into that object. But if we did want some validation, we could create an object literal here and specify specific properties and the types of those properties if we so desired. but in this case, we don't really care. So all we're doing is validating that it is actually an object. Fact description is a string. And now something we haven't seen yet, which will be updated at. So this is just so that we can keep a track of each item in our database and know when it was changed. And this is just going to be a date. So we could just do this and just say it's a date. So all of these things here, date and string, object, these are actually just the native JavaScript types. It's nothing about Mongoose going on here. These are just native JavaScript types. And Mongoose just understands what they are when we're specifying that that's what the type of each property is. But instead of just saying it's a date, we're actually going to give it a type and a default value so that we don't have to keep setting it. Instead, Mongoose will handle that for us. So to do that, we'll just give it an object. We'll say type equals date. So now this is exactly equivalent to what we did have 5 seconds ago. But we'll give it another property called default, and that default will be date.now. So that is just the current time. If you call that as a function date.now, it gives us the current timestamp. And then that will be called every time a fact is updated in the database. So Mongoose will handle that updated at property for us behind the scenes without us needing to worry about it. So that's the basic schema created, and now we can use that schema to actually create a model in the database. So what we've just created here is just a structure. It's not actually linked to the database in any way. So we need to link it to what's called a collection in Mongo and say that this collection is structured using this schema. So anytime we ever try to put data into that collection, it will validate it against this schema. And if it doesn't match, it will throw an error and not allow us to put that data in. So we can do that. Say const fact equals mongoose.model, and then we give the model a name. In this case, we'll say it is the fact model, and then the second argument is the schema. So that is just fact schema, like that. And now that we have that fact model, I'll just quickly add it to the exports so that we have access to it from other files. So that's all we need to do with Mongoose to validate the facts within the database. So now let's do the same process for the questions. So we'll just save this file and we'll hop into the questions. So again, we'll just import Mongoose like we did before. Just like so. And then we'll say question schema equals new mongoose.schema. And again, we'll pass it this object. And now we can just fill this in with the properties we need for our questions. So we'll give it a question type. Again, that'll be a string. So that's in our questions. We have image question types. We have text question types. So this will be the property that holds whichever question type it is. There'll be question text. That's also a string. And now we have a slightly different property. This is question possibilities. And this is actually an array of objects, and then each object has a possible answer in it. So we do that by giving it the square brackets. That tells us we're expecting an array. And then we can put an object in there and give it a property of answer and say that an answer is a string. And Mongoose understands that this defines a type that's an array that can be any length, and every item in the array must be an object that has an answer property that's a string. So that's quite a lot of complexity embedded into quite a simple bit of code. We've got 3 nice, neat lines of code here that are defining quite a complex schema, quite a complex validation of structure of our data using very simple code. And this is the beauty of something like Mongoose, the object model, that if we had to write this validation code every time we try to insert something into the database and we had to validate that it was the right kind of object and that each object had the right types in it, the right properties and all that sort of stuff, that can be quite a lot of code to have to write. And it's going to be quite cumbersome to write that, to maintain that. And you could potentially open yourself up to some security risks if you miss some validation here and there. But Mongoose allows us to use all of that complexity in a very simple piece of syntax. So that is one of the advantages of using something like Mongoose. But continuing on with our schema here, we have a correct answer, which is a string. And then we have the updated at property, which is just the same as we had in the last. one where we have a type, which is a date, and a default value, which is date.now. And then we will create that question equals mongoose.model. It is our question model, and we'll give it the question schema. And then we'll just export that so we have access to it. So now we have the schemas done for the questions and the facts. But one thing we haven't done yet is we haven't actually connected to a database on our system. We've defined what the structure of the data should be like, and we've defined what collections those structures are related to, but we don't have a connection to a real database running on our system. So that's what we'll deal with now. So I'll come over here and I'll create a new file, and I'll just call it db.js. We'll open that up. And as always, we're going to need to require in Mongoose, because that's what we're using to interact with our database. So we'll do what we've done before, Mongoose. So the syntax to connect to a Mongoose database is something like this. We say mongoose.connect, and then we give it a string, which is a URL to a MongoDB instance. And then as a second argument, we give it an object, which is the configuration object, the options that we want to use to connect to that database. So in this string, I'll connect to MongoDB // so that's the protocol we're using. So on the internet, we have like http://, and that's telling the URL that we're using the HTTP protocol. Here we're using the MongoDB protocol. So we're going MongoDB:// localhost, and then we give it a port number. The default port number that Mongo uses is 27017. And then we give it /, and the path after the / is the database we actually want to connect to. And we'll call this Turtle Quiz. So the Turtle Quiz database hasn't actually been created. We've just installed Mongo, or hopefully you have, and you've got Mongo running, but we've never actually created this database. But Mongo, and Mongoose specifically, is clever enough to understand that when we're trying to connect to this, if it doesn't exist, it'll just create it for us. So we don't need to go to the hassle of creating the database independently. Just trying to connect to a database that doesn't exist will create it for us. So that's why we've got that. And then into our configuration object, we'll just give it a few options. The first option we'll give it is use new URL parser and set that to true. And we'll give it a keep alive equal to 1. I'm not going to go into what options you can pass Mongo. These are some good defaults, but the Mongo documentation lists all of them that you can use, and you can go through that in your own time to figure out what ones you might need in your application. So this is how we would connect to a database. So we could just leave this. We could import this file into our main index.js, and it would create a database connection using Mongoose. And we could then use our schema and put things into the database, fetch things, etc. But the problem here is, what happens if the connection fails? The rest of the app doesn't know about it, and the rest of the app will continue to work, and Mongo's failed, and then we have this inconsistent state where we're trying to read from a database that we're not even connected to. Not good. And also, it might successfully connect, but then it errors out in the future, or it disconnects, or something happens. And again, the app is not going to know about it. There's no strategy to try reconnect, none of that sort of stuff. So this is quite a brittle, not very robust way of handling this. So instead of just having this command like this, I'm going to put it inside a function where we're going to then use some other parts of Mongoose to add some extra functionality like reconnecting and only spinning up the rest of the app when the connection to the MongoDB is successful. So we'll do that by creating a function. We'll call it startDB, and then in here I will put this code, the Mongo Connect code here, and this actually returns a promise. So we can say .then, and just when it connects, we'll just say console log MongoDB successfully connected, something like that. But MongoDB actually has another interface that allows us to add asynchronous callbacks in more granular ways. And the way that we access that is using mongoose.connection, and then we can use .on, and just like in jQuery, if you're used to that, you could say on click or on mouse down or something like that. We could say on error and give it a callback, and we'll just give it a console error as the callback, so it'll just console error out whatever the error is. And we'll give it on disconnected, and then when it disconnects, we'll call startDB. So this is like a recursive thing. It will call itself whenever it disconnects to try and reconnect again. And we'll actually return this so that we can continue to chain these callbacks when we call startDB. Because maybe we want to have separate handling of certain events after we've called the startDB function. And one of those events is going to be when we actually successfully connect to the database. So we have this startDB function. So let's just export that out. Module.exports and put in startDB here. And then we want to import that into our main index file. So we'll import startDB equals require DB. And now we've got this app.listen down here. And that is when our app is actually spun up on the server and we're actually listening for incoming requests across the internet, right? But what I'm going to do here is we're going to connect to the database, and then once that connection has been opened successfully, only then will we bind the Express app to a port. Meaning, if the database fails to connect, the app doesn't actually correctly spin up. So then we don't end up with this inconsistent state where the app is actually listening for connections and listening for requests, but it's not connected to the database. Because there's no point listening for requests because we can't actually serve them if we're not successfully connected to the database, right? So by trying to open up a connection to the database and only actually binding Express to a port on the server when that database connection is successful, it keeps our app state a lot more consistent. So we've imported startDB. So now we can just use that. We can say call startDB as a function. But then because we returned that Mongoose connection, we can now continue to chain things. So we use .on a couple times in the db.js file, but there's another callback called .once, and .on is just a forever alive callback. So every time we have a .on disconnected, every time the database disconnects, we'll call that callback function. .once, as the name suggests, will only actually call this callback once. So even if it happens multiple times, you'll only actually trigger the callback on the first attempt. So we'll say .once, and the event we want to listen to is open. So when the connection to the database is successfully opened, and then we'll give it a callback, and it's in here that we'll put our app.listen. And now our Express app will only bind to the port when we're successfully connected to the database. Exactly what we want. Perfect. So what we have at this point is correctly defined schemas for our data, our facts and our questions. We have the ability to connect to the database when we want to, and we've got a nice pipeline where the Express app only spins itself up when we have a database connection. So the next obvious thing to do is take the data that we've got in data.js and put it into the database. And that's something that's often called a migration or a data migration. So we'll do that by creating a migration.js like so, and we'll open it up. And then inside here, we're going to want to require in a few things. So we're going to want the startDB function from our db.js. We're going to want the Mongoose model definitions, question and fact. And we're also going to want all of the data from the data.js file. So let's import that now. So now we're going to want to create some functions that take the data from the data.js file and put it into the database. So we'll start off by creating a function, and we'll call it migrate questions. And here we're going to want to loop through all of the questions in the quiz questions array and then use that to build a new object that conforms to the structure of the question schema, and then we'll put that into the database. So we'll loop through that quiz questions array. And we'll grab hold of the current question at index I. And we're going to want to grab hold of the correct answer. But if you remember the structure of the data, in the quiz questions array, we have possibilities, and there's 4 possibilities, but there's no indication of which is correct. But then there's a separate variable called correct answers, which tells us which index in that possibilities array is actually the correct answer. So we can use that to grab hold of the correct answer. So that's going to be, put it to a correct variable, and it's going to be q.possibilities, and then inside that it's going to be an index. And to grab the index that is the correct answer, we use correct answers I. And we use I here because the correct answers I is the correct answer for the ith quiz question, which is the question that we're currently working with. And then from there, we'll grab hold of the actual answer. So now we have enough information to build an object that conforms to the question schema. So we'll do that by saying const data equals this object, and we'll give it a question type, and that equals q.type. We'll give it question text, that's q.text. We'll give it question possibilities, and that's q.possibilities, and a correct answer, which is just the correct variable we created above. So now we have that object, we can insert it into the database, and we'll do that by saying question.create and pass it that data. So we can use question.create, which creates a new question in the database, in the questions collection within MongoDB, and we're adding the data object. And then Mongoose will validate that data object against the schema, and if it is valid, it will be inserted into the database, just what we want. So what's happening here is we're looping through every question and inserting into the database. But this question.create is actually an asynchronous operation, so it returns a promise. But what I want to happen here is that we only return from this function when we've successfully inputted everything into the database. But of course, if we just returned a promise, the function would return immediately. But we're actually looping through all of these questions and creating a new promise for every time we insert a question. So which of those promises do we return? We'd have to wait for them all to successfully resolve. So then how do we do that? I mean, we could create an array with all the promises in and then use promise.all or something like that to resolve a new promise when all the others have resolved and blah, 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 blah. It gets really complicated and kind of hairy to deal with, and that is the way we used to have to deal with it. But using modern JavaScript, we have a tool at our disposal called async await. And async await allows us to treat a promise as if it was synchronous, meaning we just wait for it to return and then continue execution. So let's go up here and we need to mark this function as async. That tells JavaScript we can put await statements inside this function. And now down here, we'll say await. And what that's doing is telling JavaScript, wait for this promise to resolve before you continue execution. So in practice, this for loop is going to loop through the first element, try insert it into the database. It will wait until it's successfully put into the database, and only then will it go back to the top of the loop and go on to the second element. And then that will wait for that until it goes on to the third, and so on. So by the time we get to the end, and we break out of this for loop, and the function returns, we know that we've successfully put everything into the database. And that is the beauty of async await. We added 2 extra words into our code, and we've simplified it by orders of magnitude. It's wonderful stuff. So now let's create another function that does the same thing and takes the facts information and puts that into the database. So again, it's going to be an async function. We'll call it migrate facts. This time we'll loop through all of the turtles data array and put all of that into the database. We'll grab hold of the current fact object there. And then we'll create a facts object, and this will be the object that is in the correct structure for the schema. We'll give that a fact type, data.type, fact image URL, data.image URL, fact data, and this is an object. And if you remember back to the schema, we define this as just being an object. So we can put whatever we want in here because there's no extra validation. So we'll put in the locations, that's data.locations, size, data.size, diet, data.diet, And finally, lifespan is data.lifespan. And finally, we'll give it a fact description, and that is data.description. And again, we will await fact.create and pass it the facts object. And there we go. So now we've got two functions that migrate the data from the data.js file into the database. But we haven't called the functions yet. And even if we did, they wouldn't work because we haven't got a connection to the database. Because the only place that we have a connection to the database is when we call startDB. And we're only ever calling startDB in the main app's index.js file. But this migration script is going to run separately from that, so we're going to need a separate connection to the database. And you may have noticed that we actually imported startDB, but we haven't used it yet. So that's a pretty good indication that we're going to need to use it now. So down here, I'll create another async function, and I'll call it migrate. And then here I'll call startDB, and we will await the migrate questions, and we'll await the migrate facts. And then at this point we will do process.exit. And the reason we need to do process.exit is because we still have a connection to the database open. So typically what happens when you run a script is it runs through all of the code in that script. When it reaches the end, there's no more code to run, so it assumes you're done. Well, it knows you're done because there's nothing else to do, so it just closes the script, it exits the process. But in this case, even though all of the code has run, we still have an active connection to the database. So the script, or the process, has no way of knowing that we're done. So we need to manually exit the process because we know we're done, so we need to kill it. So we use process.exit here. But something you may ask here is how can we call await on something that doesn't return a promise? Because migrate questions and migrate facts, they don't actually return anything, never mind a promise. And I said earlier that await is just this new way of dealing with promises. So how can we use await here? And the reason is the nature of the async keyword. So we marked the migrate questions and the migrate facts functions as async. And that tells JavaScript, treat these functions as if they're asynchronous, so we can deal with them in asynchronous manner. And by that, I mean we can use the await keyword. So even though we're not actually returning a promise, the fact that asynchronous stuff is happening, i.e. we're using await inside those functions, if we then use await in this migrate function and await migrate questions or migrate facts, it will also wait for everything that needs to happen in those functions. And it will go recursively down the function call stack as well. We'll only move on to the next line of code in this migrate function when everything in the other functions is done. And then we call process.exit. But think about how we would have to do this if we weren't using the async await. We couldn't just call process.exit at the end, because we need to make sure that all of the database stuff is done before we kill the process. Otherwise, we're killing the process when there's work happening, and we don't want to do that. So maybe we would have to do the promise.all thing again, where we'd save a variable for the return value of both of the function calls and then use promise.all to create a new promise that resolves when they're all done. And again, like I said, that is not a nice solution. But async await gives us a perfect, clean, sequential order flow here, which is exactly what we want. So now we just want to call the function. So we'll just call migrate, and we'll close out of here. And then we'll just say node migration.js. We'll run that, and you can see the process exited, so that's good. And we just got one console log out there, which is the successful connection, and that's from the startDB function when the connection's successful. But we've run that, so now, hopefully, we have some data inside our database. So we'll open Vim back up, and we'll open up facts.js. So we can see here, we're just using promise.resolve to immediately resolve the turtles data that we got out of the data.js file. But this time, we're going to want to fetch the real data out of the database. Just like we used the Mongoose model to add data into the database, we can use that same model to fetch data out of the database. So if we remove this line, we can instead return fact, which is the Mongoose fact model, .find. And that will return a promise that will resolve to all of the facts that are in the database. So we can build more complex queries if we want to, where we're selecting things based on an ID or a certain field or any other sort of information. But for the purposes of this tutorial, we want to fetch all of the facts that we have in the database. So we just want to return fact.find, and then that promise resolves to all of the fact data in the database. And that's us done. We're fetching the facts. So now we can do the same process in the question model, which is going to be a little more complex because we're going to have to change the data before we return it from the model. So as we can see here, again, we've just got these promise.resolves. So we'll remove that and we'll return question.find. But this time we want to change the data a little when the promise resolves. So we'll do that by chaining on a then, getting hold of the data. So this function is supposed to return the correct answers. And in the data.js file, correct answers was just an array with the index of the correct answer for each question. The problem with that is we want to potentially randomize the questions, and the location of the correct answer is not always going to remain fixed. So instead, what I'm going to return from this function is going to be a map that maps the ID of a question to the correct answer. So then it doesn't matter what index the correct answer is, as long as we know the ID of the question, which Mongo assigns to every question automatically, then we can find the correct answer regardless. So we'll do that using a bit of functional JavaScript, using something called reduce. This isn't a tutorial about reduce, but very simply, reduce just takes an array and reduces it down to another data type. It could be another array, but more often it's going to be a number or an object or something. And in our case, it's going to be an object that's going to be our map that maps the ID to the correct answer. So this will make a bit more sense when we write the code. So I'll just say data.reduce, and then into reduce, we give it a function. And it takes two arguments, which is the aggregate value and the current value of the array iteration. And then we give it a second argument, which is the initial value to start off the aggregate. In this case, we'll just give it an empty object. And then through each loop of this reduce, we take the aggregate and we're going to assign a key to it, which is going to be val._id. And _id is the ID assigned by MongoDB. So we're going to create that value and we're just going to set it to val.correctAnswer. And then return the aggregate. So what this is doing is we've taken all of the questions out of the database, which is an array. We're looping through each item of that array using reduce, and then creating an object where we take the ID of that question and assign that key the value of the correct answer for that question. And then we end up with this whole big object that maps those IDs to correct answers, and then that's what we're returning from this whole function call. And by doing it this way, if we send that object back to the front end, instead of trying to guess indexes, we can just look up the ID of the current question to find the correct answer. And then it doesn't matter the order of the possibilities on the front end. We always know which is the correct answer. So it's much cleaner, much easier to reason about. So now moving down into the get quiz questions, we'll remove that. Again, we'll return question.find. So we want to find all of the questions from the database. And again, we're going to want to do something with the data. So we'll chain on a then call. So this time, what we're going to want to do is again, loop through all of the questions. We're going to want to remove the correct answer from the object because we don't want users to potentially be able to cheat by knowing what the correct answer is. We're going to want to add that correct answer into the possibilities and then shuffle everything up. So the correct answer is always a possible answer, but it's in a shuffled order, so we never know which one it is. So let's do that now. So again, we'll use a functional piece of JavaScript to loop through this because we want to loop through the array and return a new array. So we'll use something called map. So data.map. This time again, we give it a function. We'll pass it the question. And this queue that gets passed in may look like a JavaScript object, but it's a special kind of Mongoose object. But we're going to want to convert it to a JavaScript object so we can do a few manipulations to it. So we'll say const data equals q.toObject, and that converts it into an actual JavaScript object. and then we'll grab hold of the answer. That equals data.correctAnswer. And now that we've got hold of that correct answer, we can delete it from the object. So we can delete data.correctAnswer. And now we can push that answer onto the possibilities array. So we can say data.questionPossibilities.push, and then we'll push an object that has an answer property. So this is another piece of ES6 syntax. So before, you might have seen when we want to create this, we might see something like this, where we're assigning an answer property to the variable we have called answer. But instead of having to do that, modern JavaScript allows us to do this, and it's smart enough to know that we want to use our variable called answer and assign it to a property called answer on the object. And it's just much nicer to write. So we can take that. But of course, the problem here is that the correct answer will always be the last possibility in the array. So we're going to want to shuffle things up so that we don't know which one is actually the correct answer. It's always going to be random. So I'll call a function called shuffle that we'll create in a second, and we'll shuffle data.questionPossibilities. And that'll just in place shuffle that array so that it'll always be random. And then from there, we can return data. And one extra thing that I'll do is just here, I'll loop through the question possibilities just so that I can return the answers. Because right now, these objects will actually have a Mongo ID, and I want to just remove that Mongo ID. So we'll just say question possibilities.map q and just return an object as an answer property, and the answer is q.answer. So this is just cleaning things up a bit. So before we have an ID for each possibility in Mongo, but then we're pushing the answer onto that possibilities, and that obviously doesn't have a Mongo ID. So again, users might be able to cheat by looking at the data returned, and the one without the ID is the correct answer. So instead, we'll just clean things up so that everything is just an answer property, no other keys, no IDs or anything like that. So now the next thing is creating this shuffle function. So shuffling is kind of this weird thing because obviously computers can't do true randomness and there's all sorts of issues there. Here we don't need perfect shuffling. So we're going to use something called the Fisher-Yates algorithm. So we're not going to go into what that is. I'm going to just speed through typing it out. You can read about it online. It's just called the Fisher-Yates algorithm for shuffling. So there you go. That's the Fisher-Yates shuffling algorithm. I'm not going to explain how it works or go into detail about it. So there's plenty of information on the internet explaining exactly how this algorithm works. This is an ES6 JavaScript implementation, but there's literally hundreds of implementations floating around the internet in various different languages if you want to sink your teeth into it. But now if we just remind ourselves what's happening, here we can see we're shuffling the question possibilities and then we're returning the data. So now, if we haven't made any silly typos, we should be done. So if we hop into the browser, we can hit a few endpoints and see if we're getting some data back. So we'll hit the data endpoint and we can see we're getting some data back. And if we look closely, you can see we have an _ID property, and that's indicating that this information is actually coming from the MongoDB and not the data.js file. Perfect. So now if we just test out some other endpoints, we can go to the questions endpoint, and there we can see we have questions.
Hello darkness, my old friend. I've come to talk with you again.
And we have a problem. We can see we've got _ID properties here in our question possibilities. But we went through that map before to try and get rid of them. So we must have made a mistake somewhere. So we'll hop back in and take a look at what that mistake was. And here, there you go. The silly typo. Programming in a nutshell. We forgot something. Shocker. So we're looping through the question possibilities using map, but we're not actually reassigning that question possibility. So it never actually changes. So here we just say data.questionPossibilities equals the result of that map. And we'll put that down there to clean it up a little. We save that and let's go back into the browser and hit that endpoint one more time. We'll refresh the page and there you go. We have the question possibilities with only an answer property and not the _IDs. So now the final endpoint to test is the answers endpoint. So we'll go here, we'll say answers, and there we go. We have our map where we're mapping the question ID to the correct answer for that given question. And with that, we have a finished API for our quiz. So I really hope you enjoyed this series. I hope even more that you learned something from this series and that you'll be able to take that knowledge forward and build your own more complex Express APIs. So if you liked the video, give me a thumbs up, hit the subscribe button, hit the bell to get notifications on my uploads, all of that sort of YouTube-y stuff. If you do really like what I'm doing, I have a Patreon page where you can help support me by joining my community. You get access to a Discord group and some behind-the-scenes content, maybe some early releases, things like that. But otherwise, until my next videos, stay hungry and keep coding.